Welcome back to Cartesis Math. So in this video, we are doing finding the equation of a line when you are given 2 points. Okay, so for this first question, it's asking what is the equation of the line that passes through both points A, -2, -12, and B, 7, 42. So a few things to remember is, first of all, well, what is the equation of a straight line? So this is kind of your general form of the equation. So if you remember that, it's y equals ax plus b. So this is kind of all types of linear equations, right? And then you do have those special cases of direct, where it's just y equals ax, and constant, where you don't have a slope, where it's just y equals b or a number, right? But we are looking kind of as, we don't really know in this case if the line that passes through A and B, if they are a direct or if they are a constant, we don't know that. So we're going to be using that general equation of y equals ax plus b, since this one here works for all lines, whether they are constant lines or whether they are direct lines. Okay, so that's the equation. And then the other thing we need to remember is what exactly this equation means and what that looks like on a graph. So if I just put a quick little graph in here to remind us of what this is, if we have a line on this graph, this line will have a slope or a rate of change, which is this over here, the A. So that is our slope slash rate of change. And we find that by doing the change in y over the change in x. So the vertical change over the horizontal change. And the other formula that we have for that is y2 minus y1 over x2 minus x1. So that's the same thing. The change in y is the same as y2 minus y1. And where we see that on the graph is between any 2 points, the way that it changes vertically and the way that it changes horizontally. Okay, so that vertical change over that horizontal change, that altogether is your slope. And then the other thing that we have in here is our initial value, or y-intercept. So those both mean the same thing. They're usually just used in different contexts. So initial value is really used in word problems, since this is really your starting point. It's your starting value, your initial value. So that's the word we usually use when we're talking about problems, like word problems. But when we're talking about kind of just this line as a geometric object, it's just a line in a coordinate system, then we'll really use the word y-intercept instead of initial value, since we know that lines go on forever. And this isn't the initial value of this line. This line actually does go on forever in both directions. And so when we're talking about the line as a geometric object, we'll use y-intercept, since it's just where the line crosses the y-axis. And that's what the two different words mean. Okay, so that's a little review of what exactly it is we're looking for. So we're looking for this equation for the line that passes through these 2 points. So we have -2 and -12. So that will be somewhere on this, probably somewhere here, A. And then we have B, 7 and 42, which will be somewhere up here. Okay, and of course this graph is not drawn to scale, just so that we have an idea of which quadrant it is. B is a plus and a plus, so it's going to be here somewhere. And A is a minus and a minus, so it's going to be down here somewhere. So what we've been doing up to now, when we put the equation of this line together, is we've always been given the picture with the points kind of very clearly identified. So what we've been doing up to now is, well, we figure out the slope by counting our squares on our graph, and we find that number and use that as our slope. And then we would check, well, where's the line crossing the y-axis? And we would take that number and we would just put it in as b. But in this case, we don't actually have any of that because we're not being given a graph of A and B. The only thing we're being given is the points. So this is how you find the equation of that line without the picture. So now I'm going to just get the picture out of the way since we don't really need it that much anymore. And this is going to be important, so we'll leave this over here. We'll leave it down here actually. Okay, so we're really going to be working off of this equation. So I'm going to rewrite it here. And the first thing that we need to find is slope. And just because we don't have little lines that we can, or little boxes that we can count on a graph, we do have the other formula for slope. And this is the formula that's more useful when you are being given coordinates. When you're looking at a graph, it's a lot easier to just count them and to put, the vertical change over the horizontal change directly. But when you're being given coordinates, then this is really the formula that you want to be using. So we're going to start by finding our slope. We're going to use that formula. So y2 minus y1 over x2 minus x1. And your first step is always to label. Labeling is very, very important. So here you have your A coordinate. So this is going to be your first coordinate, which means this is your first x, this is your first y. So we have x1, we have y1. And then here, B, this whole thing is your second coordinate. So this is x2 and y2. Okay, and now all it is plugging in these numbers in the right spot in the formula. And this is actually harder than you would think because of all of these negatives on the A side. You have to be very, very careful with those negatives. So B gives us y2 of 42, and y1 comes from A. So this is where we have to be careful. Y1 is negative 12, but the formula already has a negative in it. So you're going to get minus 12. I'm going to put a nice highlight over here, since this is where a lot of people make mistakes. So if you're going to watch out anywhere, this is the spot where you really need to watch out. So same thing for x2. So our x2 is 7, and then our x1 minus 2. And now we can rewrite that with the changed signs, or if you feel comfortable, you can just do it directly. So this will be 42 plus 12. 42 plus 12, and then on the bottom we will have 7 plus 2. That's going to give us 54 over 9. And you can do that division. 54 divided by 9, that gives us 6. So 6 is the rate of change, or the slope. Now that that's done, we have one of these. We have our A. Check. Now, when you're solving for an unknown, you can only have one unknown. So right now we have 1, 2, 3 unknowns, which means I need to figure out, either x, y, x, or b. And something to notice is that we actually do have y's and x's that we can use here, because we know that this line goes through these 2 points. So we can use either point A or point B as our x and our y. And it does not matter which A or which B, which point we use. And it doesn't matter because both of these points are on the same line. So A and B, since they're on the same line, they're both going to give you the same result. What I like to do is pick the one that looks a little easier to work with. Since B is all positive, I'm going to pick B. So my y is going to be 42. My A is 6. My x is 7. And I'm now solving for B. So we rewrite this, 42 equals, and now 6 times 7, that's also 42. Look at that. So now we need to isolate B, and we need to move 42 over to the other side, or subtract 42 from both sides. 0 equals B. And this means that this line that passes through A and B is a direct variation linear function. The thing is that until we solved for B and got 0, there was actually no way for us to know that. So y equals 6x. That is the answer here. And it is a direct variation. Okay, so now moving on to question number 2. We're going to do the same thing. We're just going to do it a little bit faster now. So what is the equation of the line that passes through both points, A, -2, -5, and B, 3, 15? So we always start with our equation, y equals ax plus b. Okay, step 1 here is find slope. So we need to label. So A equals y2 minus y1 over x2 minus x1. Y2 is 15. Y1 is -5. X2 is 3. X1 is -2. So here we have 15 plus 5 and 3 plus 2. We get 20 over 5, which gives us a result of 4. So 4 is the slope. So find slope. Step 2, plug in slope and 1 point to solve for B. Okay, so this is really step 2. Now I'm plugging in my slope that I found in step 1, and I'm plugging in one of these points. The easier one to work with is always the one that's positive, so I'm going to work with the one that is positive. So y is 15, a is 4, and b is, or x, I should say, x from point B is 3. So 15 equals, now 4 times 3, 12 plus b. Now to get b by itself, we need to subtract 12 from both sides, and we get 3 equals b. And now your step 3 is write out the equation of the line. So y equals, 4x plus 3. And that is the answer. And something that I should mention is that when equations are fully written out, the only thing that should ever remain as a letter in the final form of the equation of a line is the y and the x. So this format here, y equals ax plus b, this is the very, very general form of what the equation of a line looks like, but we know that a and b are supposed to be numbers. These are both numbers. So in order for us to actually describe a line, a and b have to be numbers, y and x have to be letters. The only time we replace y and x with a number is when we're missing a letter and we need to solve for it. So in this case, that's what we're doing. We're using one of the points that we have, plugging it in order to go backwards and solve for our b. And we find our b, and then we have to rewrite the full equation in the proper form where only y and x are letters, and our slope and our initial value are written out as numbers. Okay, so that is how you find the equation of a line when you're given 2 points.